Now that we have discussed substitution reactions in great length, let's move on to now elimination reactions. So this is again a competing reaction with substitution reactions. You have two substitution mechanisms, SN1 and SN2. In addition to that, we have competing elimination reactions that can also occur, and we're going to cover that now. So whenever you have an alkyl halide and a base, one of the things that can happen is you can get an elimination product. So this base, sodium ethoxide, can remove one of the hydrogens on this carbon at the end, or this carbon here, one of these two hydrogens. So the reason why those are the chosen hydrogens is because they are adjacent, or they're attached to carbons that are adjacent to the carbon that has the leaving group. So those are the only ones we want to look at. Now, if we remove one of these two hydrogens on the left, we're going to end up with this alkene product. And if we remove one of these three hydrogens, we end up with a double bond there, which is this alkene product. Notice this alkene product is favored over the least substituted alkene. This is called the decisive product. It's named after this chemist that discovered this pattern in elimination reactions. We call it now the decisive rule, which basically says in elimination reactions, we usually obtain the more substituted alkene product. And it's not just any alkene product, it would be the alkene product that would form from eliminating the hydrogens on the carbon, which are adjacent to the carbon that have the leaving group. Here is another example of an elimination reaction. We have sodium ethoxide being added to this tertiary alkyl halide. The base can remove a hydrogen from this carbon here at the end, or this carbon here. Either one will lead to a less substituted alkene. So double bond here or here, it would not matter. It would be the same product because of symmetry. The more stable product would be the one that forms by eliminating one of these two hydrogens. That leads to this alkene product shown here, which is the decisive product. The decisive product is the more substituted product, and it is typically the most favored alkene product in a typical elimination reaction. There are exceptions to this rule. So those occur typically when we use a fairly bulky or sterically hindered base. So a good example is when you have sodium terbutoxide. So we have a terbutyl group next to this oxygen, which sterically hinder that oxygen. So because this oxygen is sterically hindered, it's going to have a hard time going after a hydrogen here, for example. So it would prefer to go after one of the hydrogens on the more accessible carbons, which are at the very end of the molecule. So the major product from this reaction would be a double bond that forms, let's say, from removing this hydrogen or this hydrogen, we get the same product, double bond there or double bond here. This is what we call the anti-decisive or the Hoffman product, named after another chemist. This is the typical product that we get when we use a bulky base. Notice the decisive product, the more substituted one, is the least favored in this particular example. Over the next few slides, we're going to cover the different possibilities for a mechanism in the elimination reaction. So similar to substitution, there are multiple possible mechanisms for elimination reactions. In fact, there are three that we're going to cover.